All right, here they give me an angle measure. It's 150 degrees, and they want me to find two positive and two negative coterminal angles. So for coterminal angles, for degrees, we always add or subtract 360. I'm going to be adding 360. It gives me 510, so that's one of my answers. But we can kind of do this as many times as we want, so I can add 360 again, and so that'll give me 870 as my second answer. And like I said, I need to also subtract 360, so 150 minus 360, which for that, you actually do 360 minus 150, and that'll give you a negative 210. It's negative because if you just look back, we were originally trying to do a positive minus a negative. All right, so then remember I can subtract 360 again, which now that we're doing kind of a negative and a negative, this is actually adding, so that's going to be negative 570. So those are my four answers there. All right, next up here we got number 2, and for this one we're trying to select all the ones that apply here for the sequence 2, 10, 18, and 26. So the first thing I notice here is that we have a +8 pattern. So I'm going to keep that in mind. That kind of tells me that this is arithmetic. But before I get into my arithmetic formulas, I see that these two right here are recursive versions because they give me the a sub 1, and it's based on the previous term. And so as I look at that, as I describe the pattern, it's a +8 pattern. So I'm going to say that E is incorrect and D is correct because that describes that +8 pattern in the recursive sequence. Now for the explicit formula. The big idea on the explicit formula actually is that I should be able to, since this is a sub 1 and this is a sub 2, I should be able to plug in a 1 and get out 2. I should be able to plug in a 2 and get out 10. And so if I check option A here, 8 times 1 minus 6 gives me 2, and 8 times 2 minus 6 gives me 10. And so you can keep checking, but that one's going to work out here, and so I'm going to say A is correct. And I can kind of see that means that B is incorrect, because if you do 8 times 1 plus 2, that gives you 10. So that's incorrect. It's giving me the kind of the wrong term there. 10 is a term in the sequence, but it's not a sub 1. I'll go ahead and check C next. So if I plug in here 8 times 1 minus 1 plus 2, you can see that's 8 times 0 plus 2, and that is 2. And then 8 times 2 minus 1 plus 2, and that gives me 8 plus 2, which is 10. So both of those check out again, so I'm going to say that one's correct. Part F here, option F. If I try that one and I plug in a 1, that would be that would actually come out to 2 times 1, and that one does check out. But when I plug in a 2, that's going to come out to 2 times 8, which is 16. So that's not correct, and so I would just say that this is A, C, D, and E. All right, next up here, we're going to solve the triangle, except we're just going to set it up. So we're going to kind of put what we would put in the calculator. So since I know this one's pi over 10, I know this side's the opposite, that's the adjacent, and that's the hypotenuse. So to find side A, I would use sine of pi over 10 equals A over 43.8. And so if I multiply the 43.8 over, I would say that A equals 43.8 times sine of pi over 10. So that's for part A. For part B, I'll let you guys try that one. For part C, it says find the measure of this other angle, angle B here, and give your answer in radians. So if we're doing this in radians, the whole triangle in radians is actually pi radians. You kind of think about it, a whole triangle is 180 degrees, but in radians, that's actually pi. And I need to subtract out the right angle, and the right angle in radians is pi over 2. And then I also need to subtract out the other angle, which is known, which is going to be pi over 10. So it's kind of like us doing 180 minus 90 minus whatever that other degree is, except we're doing this in radians. So I need a common denominator for this, of course. So it looks like I can make these all a 10 by multiplying that one by 5 and that one by 10. And so that's going to be 10 pi over 10 minus 10 pi. Nope, not 10 pi. Let's fix that. It'll just be 5 pi over 10. Minus 1 pi over 10. So now we have our common denominator. We subtract the numerators, which would come out to 4 pi over 10, and I would just reduce that to 2 pi over 5. All right, next up here, we got some unit circle problems here, so we're evaluating these without a calculator. So for the first one, secant of pi over 2. Remember that secant is the reciprocal of cosine, so that's going to be 1 over x. So my x value at pi over 2 is 0. So that's going to be 1 over 0, which is undefined. All right, next up, tangent of negative pi over 2. A couple ways you can do this one. I would find the coterminal angle by adding 4 pi over 2. So that's actually asking for tan of 3 pi over 2. And so I'm going to go to 3 pi over 2 then, and I will do y over x, which is going to be negative 1 over 0, which is actually also undefined. Anytime we have 0 on the bottom, it's undefined. 0 on the top is 0. Okay, next up here, sine of negative pi over 2. Now I'm going to find that same coterminal angle here. I already did it, so I'm just going to say this is sine of 3 pi over 2. And so I go to 3 pi over 2 again. The sine is just the y value, and so that's just going to be negative 1. Lastly, cosecant here, I'm going to add 8 pi over 4 to get the coterminal angle. So that's cosecant of 7 pi over 4. And so that's over here. And remember that cosecant is the reciprocal of sine, so it's 1 over y. Or actually, I'm actually just going to flip my y value. So it's going to be 2 over rad 2 with a negative out front, because that is negative right there in my y value. Most of the time, they're going to rationalize this denominator, so I'm going to multiply that by rad 2 over rad 2. It gives me negative 2 rad 2 over 2, which is just negative rad 2. All right, next up, we're writing a recursive formula for this, and so we just need to kind of describe the pattern here. So I see it's a plus 7 pattern. So I'm going to say a sub n equals a sub n minus 1 plus 7, just describing that plus 7 pattern. Also, though, on recursive, we always have to state a sub 1, which in this case is negative 6. All right, next up here, they're giving us an angle, and they want the minimal positive. So it's like the smallest positive and the biggest negative coterminal angle. So I'm just going to start finding these coterminal angles. So I'm going to subtract 8 pi over 4, which is really 2 pi here. So that's going to give me 5 pi over 4. And I'm going to go ahead and do that again. And that is going to give me negative 3 pi over 4. And so I'm already negative here, and so that tells me that this one is my smallest positive, and that one's my biggest negative. All right, next up here, we're wanting to find all the values of negative 1 here. So cosine of pi, I'm going to go to pi radians, and then I look at the x value, and I see that that is negative 1, so that looks like a good answer here. And sine of 3 pi over 2, that, remember, is our y value, so I go down to 3 pi over 2, and my y value is negative 1. And so that one's good as well. And then next up, tangent of 3 pi over 4. Remember, that's y over x for tangent, so 3 pi over 4 is right here. And so my y over x is rad 2 over 2 divided by negative rad 2 over 2. Now that's the same thing twice, so except one of them's negative, so that will definitely come out to negative 1. So that one's correct. All right, next up, cotangent of 225. So cotangent, remember, is x over y. And so it's negative rad 2 over 2 over negative rad 2 over 2, which is positive 1. And so that is incorrect because we need it to be negative 1. Cosecant of 630. Now 630 is not on the unit circle, or negative 630, so I need to add 360 to that. So that is going to be negative 270, which is still not on the unit circle, so I have to do it again. And that comes out to 90 degrees. So it's asking me cosecant of 90 degrees. Remember, cosecant is 1 over sine, so that's 1 over y. And so at 90 degrees, that is 1. So 1 over 1 is not negative 1. And then lastly, secant of 540. I'm going to subtract 360 there to get it within the first go-around here. So that's going to be secant of 180. Remember, secant is 1 over x, and so that's going to be at 180 degrees, 1 over negative 1, which is negative 1. So that one's good. And I think the answer actually there will be G because it's all of those. All right, next up here, select all angles that are coterminal to 5 pi over 6. So what I would do is I would just keep adding 12 pi over 6 until I got to the biggest one here. So that's going to be 17 pi over 6. So that one's good. I would say that tells me that this one does not work. And then if I add 12 pi over 6 again, that gives me 29 pi over 6. And that one's not there. Okay, so I'll add it again. I get 41 pi over 6. So that tells me this one is good, and this one doesn't even have a pi, so that one's not going to be coterminal. Now I need to kind of do this again, but do it with a minus 12 pi over 6. So that's going to give me negative 7 pi over 6 for my first one, so that one's good. And then I'll subtract it again, so I get negative 19 pi over 6, which is not there. And I'll subtract it again, which will give me negative 31 pi over 6, and that means this one does not work because I kind of skipped right over it. All right, next up here, you got number 9. So they're looking for a coterminal angle between 0 and 2 pi. So I would just keep subtracting 14 pi over 7 until I got there. I'll let you guys do that one. I'm going to go on to number 10. So number 10 says, which of these has the same value as sine of 2 pi over 3? So I would first figure out what that is. So 2 pi over 3, the y value is sine is rad 3 over 2. So I'm looking for all of these that come out to rad 3 over 2. So cosine of 2 pi over 3 is negative 1/2. That's the x value at that same spot, so that's not correct. Tangent would be rad 3 over 2 over negative 1/2, since it's y divided by x. So I multiply by the reciprocal there. Oops, reciprocal, Barry. Negative 2 over 1, that is. Cross cancel, and that comes out to negative rad 3. So that's not the same as rad 3 over 2. I'll let you guys try the rest of those. I just wanted to point out here on on part D, they put the negative outside of there on part D, and so I would find cosine of 7 pi over 6 first, which would be negative rad 3 over 2. But then they had this negative out front, and so that actually becomes positive rad 3 over 2, just like a negative to a positive. So that one is correct. Once again, you guys need to try C or D. Go for it. All right, next up here, it's asking for the angle of elevation of the sun. It says this one's 215, and that's 215. And it's asking for this theta right there. So I would set this up as tangent of theta equals 215 over 215. So tangent of theta equals 1. And I know that the tangent of theta equals 1 right here. And so I know that theta is 45 degrees. All right, next up here, the software company is selling the new video game. It says the standard has 20 cubic inches and the collectors has 30 cubic inches. And we need to be 870 total. So I'm going to say 20 of the standard plus 30 of the collectors is going to equal 1870. So based on that, I can actually cross off D because they actually switched up the S and the C, and cross off C as well. Oh, I can actually cross off this one as well, and I already know the answer is A. But it said just to kind of clarify, it says 75 copies here, so I would have done that one as S plus C equals 75. You can see, subtracted the S over to the other side. I don't know why they did that. I guess if they wanted to use substitution. So that's why they did that on that first equation. All right, next up here, it's saying what would we type into a calculator if we had one to find angle X. So for angle X, I would say this is the opposite, and then this is the adjacent. And so I would say tan of X equals 10 over 9. And so what I would have to type in the calculator is X equals tan inverse of 10 over 9. That's always how we find an angle. All right, next up here, it's saying a 40-inch pendulum. And so if you kind of think of a pendulum, it's looking like that. And it could be going over here as well. And so it could be going up here as well. And so I'm going to define this 40 inches as the radius. If you kind of imagine that, if it went all the way around, that would be the radius of it. But it's saying it only goes 18 degrees here. And so what's the length of the arc? And so we're going to use our arc formula. So S equals 2 pi r. And if we're talking about degrees, which we are here, it's going to be the theta over 360, because they gave us this angle in degrees. So I'll let you guys plug and chug there. Remember, you should do that without a calculator. All right, next up here, we want the side labeled x if y is equal to 32. So if I label this side as opposite and this is hypotenuse, then we can set up a sine of 30 equals x over 32. And so now I'm going to go to my unit circle and look at this spot right here. And the sine, that's 30 degrees. The sine right there, the y value is 1/2. So I can replace this whole thing with 1/2 equals x over 32. I can then multiply both sides by 32. And I get that x equals 16. Next one here, it says it gives me the area of a sector. So area of a sector is pi r squared times whatever angle I'm looking at over the whole circle. It says it wants this in radians, so I'm going to put a 2 pi right there. And I'm just going to kind of plug in everything I know. So I know that's 18 pi. It says the radius is 4. And then we got theta over 2 pi. Now I would immediately cancel out my pi's on this side. This one, we cannot cancel the 4 and the 2 because of PEMDAS. So I'm going to say 18 pi equals 16 theta over 2. And so 18 pi equals 8 theta. And then divide that by 8. Theta equals 9 pi over 4. All right, next up here, another area of a sector. So that is pi r squared times, in this case, it's going to be theta over 2 pi since they're talking about radians here. Oh, and they tell me that this is 32, so I'll plug that in right there. I don't know what r is. And it says that theta is 4 radians. Now, make sure you put that in as 4, not 4 pi. Not all radians have a pi attached to them. And so don't assume that it has one if it doesn't. So I'm just going to use what they said. I'm going to use the 4. All right, so from here, I'm going to cross cancel these pi's. And I can say, I'm going to call this 2r squared since of the 4 divided by 2 there. And I'll divide that 2 over. So 16 equals r squared, which would mean r is 4. All right, next up here, I would want to find the 14th term of the arithmetic sequence. And so I would write an explicit formula for this. And so I see that every time we're adding 8. And so this is like dn plus a sub 0. So it's kind of like mx plus b. And so I know that my common difference is 8. So I'm going to say 8n. And a sub 0 is kind of like what is the term before the first term going this way. So I'm going to subtract 8. And that would be negative t minus 8. So I'm going to add negative t minus 8. So now if I want to find the 14th term, I can just plug in 14 here for n. And minus t minus 8. And then 8 times 14, what is that? 32 is 112. So 112 minus t minus 8, which just comes out to 104 minus t. All right, 19 and 20 are using the unit circle, so I'll let you guys do that. We've done a lot of that practice already. 21 is converting to degrees, so to convert to degrees, we always multiply by 180 over pi. And so these cancel out, and this will reduce to 9, and so that would just be 27 degrees. All right, next up we have a recursively defined sequence. We want to find the first 4 terms. Good news is we already have the first term, but for the second term, it is going to be 4 plus the previous term over 2. Whenever you see that a sub n minus 1, it's just referring to the previous term. So that is 16 over 2, so that's 8. So then a sub 3 is going to be 4 plus the previous term, which is now 8 over 2. So that's 12 over 2, so that's 6. And then the fourth term would be 4 plus the previous term, which is now 6 over 2. And that's going to be 10 over 2, so that'll be 5. So we have 12, 8, 6, 5. Next up, we got some probability here. We're pulling marbles out of a bag, not replacing them, so it's going to change on the second pull. We want the first marble to be purple, so that is 5 out of the total of 8. And then we want the second one to be red. Now there's still 3 red marbles because we're saying I got a purple on the first one, but there's only 7 total. It looks like I cannot cross-cancel anything, so I would just say it's 15 over 56. All right, next up here, they want the arc length up here. So we're using degrees, so I'm going to say it's 2 pi r times theta over 360. The tricky part on this one is that they give us this one as 120, but they're asking us about that one, which is actually 240. So I need to plug that in as 14, and then this will be 240 over 360. And so then you need to reduce that. I'll let you guys handle that. All right, this one here, describe the distribution. So I always kind of think of it like I draw a little mountain, and whichever way I want to ski, it's that way. So this is going to be skewed right. That does mean that the mean is greater than the median, because I always think of it that the mean gets skewed in that direction. This outlier out here is pulling the mean in its direction, but not affecting the median as much, because outliers do not affect the median as much as they do the mean. 26 here, we got some table probability. It says, find the probability that the car is midsize given that it is Japanese. That means I only want to look at the Japanese cars here. And so if it's mid-size, that's the 21. And then the denominator there is 9 plus 21 plus 12 plus 6, whatever that is. So I'm only looking at the Japanese car there. This next one, though, says given that it is neither compact nor subcompact. So that means I'm really only looking at these groups. And so I want the probability that it is Japanese. And so that would be 9 plus 21 up top for my Japanese out of those blue group. And then my denominator would be all the blue ones I circled. So 12, 18, 9, 21, 8, and 12. All right, next one here, we want to find the area of this triangle. It's a non-right triangle, so we can always use area equals 1/2 AB sine C. If we have two sides and an included angle, which we do here, that's going to be 1/2 times 16 times 9 times the sine of the included angle, which is 45 degrees. Now, I can turn this into 8 times 8 times 9 up here, excuse me. Sine of 45, I can go to my unit circle. I know 45 is right there. And I know the y value right there is rad 2 over 2, so I can replace that with rad 2 over 2. I'm going to do a little cross-canceling here with my 8 and my 2, so it's going to be 4. So it looks like it's going to come out to 36 rad 2. I guess that should be square feet.